All right, welcome everyone to our April edition of the OSM Community Call. Please note this call falls under the CNCF Code of Conduct. So, as I like to say, if you're nice and respectful to each other, you'll be fine. Also want to basically introduce anyone who's new to the call. So if you are new to this call and want to introduce yourselves to the community and talk about what your interests are for the project, please feel free to do so now. Okay. All right, so now let's go ahead and get into our agenda. We got a pretty quick agenda, but we do have a demo by Shashank, and he'll go through that. But first, let's go ahead and hopefully you can see my screen. Let's go ahead and just go through the milestone. We'll kind of highlight some of the tasks that we're working on for this milestone. And let me go to here. So here's our roadmap. And again, this is all public information, so feel free to take some time and go through this and see what we're tracking. I won't go through all in progress, but that is what's kind of in flight for this milestone. But what I'll do is I'll just kind of highlight some things I think are beneficial to the community. We are doing a lot of routing enhancements. We got a lot of that in the pipeline. So we got some issues concerning traffic split for same FQDN endpoints with different routes. We also have support for routes V2. So if you're not familiar, that's the RDS, the route discovery service, which will allow for dynamically changing traffic shifting. We're also looking to extend support for host header information. So to begin to be a little more granular for traffic shaping with host header information, as well as supporting the path type for the Kubernetes ingress object as well. Some other things we're doing, we're going to be overhauling our doc site here in the next few weeks. So you'll be able to experience a little more a polish on the site here. And then we're also making the experience better for OpenShift. So we're expanding our E2E testing as well. So feel free again to kind of go through all the issues. And if there's things on there that you want as far as enhancements, functionality, feel free to go ahead and create a GitHub issue for us to look at and speak about. All right, so that is the milestone recap. And next up, we will have Shashank. Shashank is going to do a demo for our TCP route functionality in OSM. And this is really important. A lot of applications, cloud native applications have need for state store, and things think of your Redis or your MySQL, et cetera, which do not operate on HTTP protocols, but a TCP port. And Shashank's going to show us how you can bring those endpoints into the mesh and be secure as well. So with that, Shashank, the floor is yours.
Thank you, Phil. I'm going to start by sharing my screen. Hopefully, folks can see it. I'm going to just move this out to the side. Okay, everything looks good.
You can see it.
Hi, everyone. Thanks for joining. I'm Shashank. I'm a software engineer, and I work on the Open Service Mesh project. And today, I'm going to demo the TCP route feature in OSM. So before I jump into the demo, I'd like to show you folks what the SMI TCP route API looks like. And we'll get started from there. And so as you can see, the SMI TCP route API is a very simple API at the moment that allows you to specify a list of ports that traffic is matched on. And as long as the TCP traffic is directed to one of these ports specified, then it's considered to be a route match. And if you're familiar with SMI, you'll know that a route in SMI is then referenced in a traffic target authorization policy that allows you to end-to-end set up policy-based routing with SMI policies. So in this particular demo that I'm going to present to you, we'll explore how to set up TCP-based applications in a service mesh, and how we can then set up TCP routing rules to allow specific ports to be accessed on the service. So without further ado, I'll just get started with the demo. So for this particular demo, I have the Kubernetes examples repo forked, and I'm going to show this example demo of a guest book because it makes use of some applications that are seen in a lot of production deployments as well, such as using a Redis backend and just the notion of having a multi-tier application set up. And so in this demo, I have a two-tier application stack where there's a guest book front end that allows users to record entries into a guest book, and a pair of Redis backend databases. The Redis backends itself are accessing or exposing the Redis protocol over port 6379, which we'll see in a bit. And the guestbook front end ends up communicating with the Redis primary to store entries into the database, and it reads entries from the Redis secondary databases. So before we get started with the demo, I'd like to show you folks what the deployments look like. The guestbook front end is nothing but a Go application that has a web service running, so nothing very interesting to see over here. The interesting part of this demo is the primary and secondary Redis services that we have. And as you can see, both of these services, both of these database services are exposing the Redis protocol in port 6379. And this is something the guestbook application will use to direct traffic to establish connections with the database. So let's get started with the deployment and see what's going on. Okay. So I'm just going to refer to this README that I have set up because it makes it easy for me to like walk through the demo. So I already have a cluster. If you can see my terminal, I already have a cluster with the v0.2 version of OSM installed. And I'm going to deploy the guestbook application and the Redis database and try to set up TCP routing for the applications to communicate with each other. So I'll go ahead and create a namespace first, which will house our applications. The next thing to do is to add the namespace to the service mesh. So once we have our namespace, added to the service mesh, we can go ahead and deploy our applications and see what's going on. So I'm going to deploy the Redis backend deployment and services and the guestbook front end and the front end service as well. And while this is getting created, I'll quickly show you folks how to set up the specs so that TCP routing is enabled. And the reason we're setting up TCP routing for this particular demo is because the guestbook application is going to communicate with the Redis backends using the Redis protocol, which uses nothing but TCP as the underlying transport. So if you look at the TCP primary service, we'll see that it's exposing the port 6379. And the important thing to note here is that there's an app protocol field that we are leveraging and that is set to TCP as a way to communicate to OSM that this particular service's port needs to be use TCP-based routing and filtering policies. If our service was an HTTP service, then we would set this to HTTP, for instance. But for this particular demo, we're setting this to TCP specifically because we want to enable TCP-based routing rules for the port 6379. So
Hey,
now that our
real quick, Shashank, before you get too deep, Bridget asked a question. So is this available with 0.8.3? Or
this
what
should
version?
be available with v0.8.3, but right now the demo, I'm using the v0.8.2 version. So it's available with v0.8.2 and with v0.8.0 as well.
And then is this Kubernetes version, is this 1.21?
So I'm using 1.19.
Okay, 1.19. Okay.
So yes, there is this caveat that the app protocol field is only available, or is rather GA, in Kubernetes version 1.19 and greater, but there is a document that I dropped in the chat earlier that allows you to specify the app protocol in versions prior to Kubernetes 1.19 as well, while using named ports. For example, if this app protocol field was not there, then you could specify a name for the port prefixed with the protocol. So I could specify a port name of the form TCP hyphen something.
Perfect. Okay. Thank you, Sean.
So let's go ahead and check out the guestbook pod. So for this demo, I'm directly going to port forward to the guestbook pod rather than trying to access or expose this service via ingress, because it just simplifies the demo a bit. So I'm port forwarding to the front end, and I'm going to show you what the front end looks like. So essentially, the guestbook application is waiting for a database connection. And the reason the database connection is down is because OSM by default is installed with the SMI traffic policy mode enabled. And as such, all traffic within the service mesh is denied by default. So we need to explicitly program policies to allow the guestbook to communicate with the Redis backend databases, but also to allow the Redis backend databases to communicate with each other and replicate state information. And so the next step is for us to define an SMI traffic target policy that allows the service accounts that these pods belong to communicate with each other, and also a TCP route policy that allows the guestbook front end to communicate with the Redis backend services. So I'll go ahead and do that. And while I do that, before I do that, I'd like to show you folks what the policy looks like. So for this demo, to simplify the setup, I have all the applications running in the same space with the default service account. And so we have a very simple traffic target policy that allows applications that belong to the default service account to talk to each other. And the interesting thing to note here is we also have a Redis route, which is a TCP route defined as a rule for this traffic target resource. And this essentially allows the guestbook application to communicate with the Redis backend over port 6379. So the Redis route policy matches on port 6379. And so any traffic that is sent by the guestbook pod to the Redis backend services on port 6379 will be subject to this policy and will be allowed by the service mesh. So the next step is to just go ahead and apply this policy and see if things start working. I'm going to go ahead and apply this policy, and then going back to the, we see that we no longer see the message related to the database connection not being established. And so now we can go ahead and add entries to our database. For example, I can add an entry called foo, an entry called bar, and this essentially is being written into the primary database by the guestbook application and rendered on the guestbook's web page by reading the entries from the secondary database here. And we'll see that if we go ahead and delete the application, or rather the policies over here, the database connections should break through again. And there you go. And so essentially what this demo has shown so far is that while setting up a simple SMI traffic target authorization policy along with a TCP route, one can control access to specific TCP ports and enable TCP-based routing within the service mesh. That concludes the demo. With that, I'd like to open it up for any questions.
So I have a question that might be kind of a basic question, but if somebody wants to use this and then maybe change it, where would you recommend people start with trying to start with, say, the basic guest book, but then use that as a model to build out something perhaps more complex? Like, where are good places in GitHub or whatever to look to say, like, oh, if you want to make this a little more complicated, make sure that you change this, or
Yeah, so for this particular demo, I found that the Kubernetes examples repo has a lot of different applications that mimic practical scenarios that are used in production deployments. So I used the guestbook Go example and I tweaked the demo a bit for it to work with OSM, such as needing to specify the app protocol. But this is a good place to look at because there's also a couple of other examples, such as using MySQL, which works the exact same way as Redis and can also leverage TCP-based routing to function.
oh, that's really good to know. That'll help people kind of extend and build on what you've already shown us and do even more.
Mm-hmm. If there's no other questions, I'll stop sharing my screen and hand it over to Bridget and Phil.
All right. Thanks, Shashank.
Thanks,
That's
Shashank.
awesome. And I'm assuming, Shashank, that works with all ingress objects in front of that as well, right? There's no restriction.
Yeah, so ingress is a bit tricky because the ingress rules are typically defined for HTTP traffic and not TCP. And I don't know if the V1 of the ingress spec has any facility for TCP-based routing. I know Nginx has some workarounds to support TCP-based ingress, but typically ingress is used for HTTP-based applications. And so TCP-based routing might not be applicable there.
But as long as you come in through your ingress, and then if there's some state store behind that pod has to communicate to, this would work on that port.
That is correct. That is
Yeah.
correct. The good thing about using TCP route is also that you could use it for non-TCP based applications. For example, if you have an HTTP based application that uses TCP as the underlying protocol, and you only wanted to do port based routing and not having to deal with HTTP L7 headers such as the methods, the paths, the host names, you could simply fall back to TCP based routing and simply use layer 4 port based routing rules in your service mesh.
Got it. Got it. I did. So I was curious. So when I looked at the spec, one thing that was obvious to me was that there wasn't a, I don't know if you can pull it up, but there wasn't a property for like service account for it under the kind. So what's actually authorizing that connection into the mesh for the TCP route endpoints?
Yeah, so the way it works is the authorization is defined by the service accounts you specify in the source and destination field in your traffic target policy.
Okay, so it's part of the traffic target. Got it.
As long as traffic matches that particular authorization policies, the routes that are specified as rules in the authorization policy enforce the routing criteria for that particular traffic. So in this case, in TCP, once the traffic matches the authorization policy, then the next level of matching is the ports that are specified in the TCP route itself. And if there's a match if the destination port matches the routes specified in your TCP route, then the traffic is allowed access to the destination service. Otherwise, it would just be dropped at the destination itself.
Perfect. All right. Is there any upper limits to how many TCP route endpoints you can have?
Not really.
Okay.
At the moment, you could specify as many ports as you want. The Kubernetes API uses the Open API schema, so you could specify how many ever ports you want in your resource itself. There could be practical limits on how many applications you could deploy within the service mesh, but those are pretty much similar to if you were using some other application protocols such as HTTP.
Awesome. All right. I won't beat you up anymore. Those are good, good responses there. All right. So I believe that takes us to the end of our agenda today. I will open it up if anyone wants to make any comments or has any questions or any discussions that they want to bring up to the community.
Hi. Yeah, probably I have something that I want to bring to the community.
Awesome.
So my name is André Fonseca. I work at the bank in Portugal, and we are using Open Policy Agent, and we are looking out for SMI and also OSM. We are a client using mainly Azure. Okay. And we are obviously looking into service meshes. We looked into various ones, Istio, for instance. And obviously on the data plane, we are looking at Envoy for all the traffic. And since we are using Open Policy Agent to do some kind of authorization in our microservices architecture, we are aiming at using the Open Policy Agent authorization plugin. That is something that was developed to install in Envoy. And we are looking, and we also have opened an issue on SMI SMI GitHub. I think that the issue is 213. Okay, that were to be discussed in there, but it is something that we want to take leverage on OSM, since we are using Azure, for instance, and AKS. So we probably want to bring that issue that we open on the SMI to here, to this forum, to discuss if it makes any sense to have this kind of integration on the OSM part, which is basically a mimic from that issue, and just to bring up that issue to the OSM community and see if there is something that is related to this.
Yeah, thanks, Andre. I know we've been chatting, so thank you.
Yeah.
Showing up to the call. So yeah, let me go ahead and I'll just quickly share my screen so we can make sure everyone has context of what we're discussing here. And hopefully I'm broadcasting. Are you able to see my screen by chance?
Yes.
Okay. And Andre, I believe you said that was issue 213, correct?
Yeah. I think.
Okay. And so I'm gonna take a stab at this. To sum this up, you're looking to have authorization via OPA through SMI for additional rules for the service mesh to authorize traffic. Is that correct?
Yeah.
All right. So I know we got several maintainers out there. Any questions back to Andre to ensure that you understand the ask, and where best should this functionality fit? Should this be in OSM natively? Should this be part of the SMI spec, or should this actually be somewhere else?
I'm not sure if I should address where it should be. I think Delian has some thoughts there, but I will say we do have the SMI community call tomorrow as well. So if we want to continue that discussion there.
Yeah.
But
Yeah.
Delian, you had ideas.
I do have ideas. They're kind of meta points, but hi, Andre. Actually, really nice to say hi to you. And I would love to also, it seems like you're connected with Phil, but so good to see kind of members of the community join us here. And thanks for bringing this up. I think, Andre, I'm Delian, and I work with this great team, all the contributors to OSM. I'm also one of the maintainers, and love working on OSM. I think this is interesting because yes, there's the SMI component to it where we need to declare somehow, SMI being the lingua franca of service meshes, you want to declare somehow this where the authorization is going to happen, or what the auth is. At the same time, the second piece is how is that actually going to get implemented into OSM? And so I think there are two things at the same time that could happen in parallel, and maybe the one can dictate the other. Dictate is a bad word. One can kind of instruct the other, right? So I think we should sit down and think about it and maybe design it in OSM in the service mesh control plane and what it's going to look like on the data plane. And then maybe that can also, then we can go back to SMI and help kind of instruct SMI, help them define a policy that kind of matches their experience. Shashank, what do you think? Shashank, you've been involved with kind of various designs and implementing various features in control plane and data plane. Maybe this is a design doc that we can bring up to this forum here.
Yeah, that makes a lot of sense. I think the starting point would be to figure out what the use case is, and then present some sort of like a design doc to the SMI community, and then take it from there. And once it gets merged as an API, we can think about supporting it in OSM.
It was actually interesting. I love that. Yeah, getting kind of Andre's specific, requirements, seeing how to generalize them. I was actually even thinking in reverse. I was thinking we figure out how that could work in OSM, and then bring in a POC to SMI to see to say here's how one possible implementation, and see how other service meshes would react to certain SMI proposal.
Right.
Yeah.
So there's a particularity here, because this open policy agent, which is basically a general purpose policy decision engine, has this plugin developed for Envoy. So it will only work on Envoy-based service meshes. So on the SMI part, that is something that should be only used on Envoy-based service meshes. This is something that it could not be generalized, because if on the data plane there is other proxy that it cannot be Envoy, it does not make sense for this plugin to work with. So that it has this particularity. So the approach in firstly deploy it on OSM, it seems more reasonable for me, because it's an Envoy-based service mesh. But yeah, we are totally open to discuss with you guys the use case. The use case is described on the issue, but it's basically to be able to forward all the HTTP traffic to this policy agent to take the decision if it should allow or deny the request that is coming to the proxy.
Very
So
interesting.
it's just basically this, and then we can take a decision if we should allow or deny the request based on the information that we are receiving. We are pointing at HTTP traffic and also gRPC traffic, okay, to be these two kind of traffic to be able to take an authorization decision, which could be based in body context, or even on the URL, or anything that we want to take the decision upon.
Very good stuff, Andre. Maybe we should start the design doc and collaborate with you. We'll start a doc and public here and solicit your feedback and help.
Feel free. I think that Phil has all our contacts, so feel free to share with everyone.
Love it. Let's collaborate on a doc and involve both OSM and SMI communities. See where we can take this. Okay. I would love to see a prototype. Yep. Thank you.
Yeah, no, I totally get the use case. I think what I'm struggling with is you're going to have kind of like this disjointed rules engine, so to speak, right? So you'll have just mesh rules, right? And then you're going to have rules that for traffic that live in OPA, and you won't really have an all-up view to that unless there's metadata being shipped between the two somehow, if that makes sense.
Interesting. Phil, that would be great to capture in a doc. I would love to. Yeah.
Hopefully that makes sense to you, Andre, because the policy agent is the policy agent, right? It's completely outside of how
right.
OSM is processing its rules,
Yeah, but basically what we are struggling with, it's just because we need to declarative from a declarative way to instruct either SMI or OSM for that matter, that we want to enable that plugin, and that we have this specific input for that plugin. It's basically that. Okay, we don't want to express on the SMI or the OSM interface the authorization parts, okay, because the input for the plugin, it's all that we need to instruct either SMI or OSM. So basically what we are I think, and I'm talking from the top of my head, but I think that the inputs are basically, hey, install this plugin, and the input is basically where the OPA is. Okay, so what to where should I route the traffic? It's basically this. Okay, it's not more, not less. So probably the only thing that we need to express is basically the input, the plugin, sorry, and all the information that is needed for that plugin to work with. We don't want to express the authorization part and everything else. So because that's another topic, and everything that is managed on the policy decision engine is outside of this scope. Okay, so we are trying to minimize the footprint, which is basically, since we are using Envoy, and Envoy has these extensibility points, which is plugins. And then all we want to do is to use a plugin, and that plugin has some specifics that needs to be translated to it. So when the plugin is installed and it's configured, it will need some kind of input, and that is something that we need to address and to provide to either the interfaces, SMI or OSM or anything else. So
Got it. Okay. Yeah, we'll let maintainers and contributors, we'll so to speak, chew on this. But Andre, will you be on the call tomorrow for the SMI community call? We can chat with some of those maintainers as well.
let me just see. It's the same hour that this one. Sorry to be asking all you guys this, but
It is just 30 minutes earlier
after
than this call.
earlier.
Yeah.
I have a meeting. So yeah, but I will try to attend to. Yeah.
Okay. Yeah. If you can't attend, you can still add to the agenda, and
Okay.
any links that you want us to look at, we can bring it up during the call as well.
Okay. At least we will do that, and at least we will put some points on the agenda. Yeah.
All right. Thank you, Andre. Okay. I believe that takes us to the end of today's meeting. Great topics. Again, thanks Shashank for that TCP route demo. And thanks, Andre, for chiming in. The OPA Envoy add-on that looks pretty interesting. We'll love to see where that lands. Our next meeting will be next month on May 11th, same time. And so again, if you have any discussion points, feel free to go ahead and add that to the agenda items, and we'll go over it then. All right. Thanks everyone for showing up. We'll see you in May.